So let's go ahead and talk about a few different types of chemical reactions. These are reactions that you'll need to know, need to be able to identify just based on the formulas alone. So when you see the formula, you say, oh, that is, in this case, a combination reaction. Okay, so a combination reaction, the first type we're going to talk about, is when two or more substances react to form one product. Okay, so what we see down here is we see substance A, nitrogen, or molecular nitrogen, and molecular hydrogen going to form ammonia. This is a combination reaction because we have two species, 1 and 2, going to form a third species here. So combination reactants have more reactants than products. This is always true. One of the important things, and this will be important once we get to chapter 6, is that if the reactants are only in elemental form, these reactions are they're a special type of combination reaction called a formation reaction. So the example down here is this first one here. We have nitrogen, molecular nitrogen, which is how nitrogen exists in nature. Notice it's in the gaseous form. Nitrogen also exists at standard temperatures and pressures in gas phase N2. Hydrogen, it's the same thing. Gaseous, and it's also a diatomic, so it exists like that. So this right here is actually the formation reaction for ammonia. Down here, this is obviously not a formation reaction because even though bromine is a liquid at room temperatures and pressures and it's diatomic, just like shown here, we also have this C3H6, okay, and this is obviously not a species in its elemental form. This is a molecular compound with two different element types. So let's go to another type of chemical reaction, and that is the decomposition reaction. This is essentially the opposite of the combination reaction. It's when one substance breaks down into two or more substances, okay? And the decomposition reaction, think of it decomposing. You know, when leaves decomposing, they're breaking down into simpler compounds. When a chemical decomposes, it breaks down into generally simpler compounds. We have calcium carbonate going to form calcium oxide and carbon dioxide. So this is actually calcium carbonate, excuse me, I misspoke. So calcium carbonate going to form calcium oxide, carbon dioxide. Notice that over here we have one species, over here we have two species, and so we have more products than reactants. The third type of chemical reaction that I want you to know at this point is called the combustion reaction. So combustion reactions, they're rapid reactions, they happen very quickly and they produce a flame, okay? And most of them, they involve hydrocarbons and they react with oxygen in the air. So down here are some classic examples of combustion reaction. This is a hydrocarbon. Remember what a hydrocarbon is it's a molecule with only carbons and hydrogens in it. Hydrocarbon? Nah, not too difficult, right? Over here we have oxygen, so these are generally the two types of reactants. Now the products for a combustion reaction are almost always carbon dioxide and water. If you're combusting, in particular, a hydrocarbon, these are your two products. There might be a third type of product depending upon the hydrocarbon. It might have some sulfur in there and be a sort of quote-unquote contaminated hydrocarbon, but you'll always get carbon dioxide and water when burning a hydrocarbon. Now if you look at the second one, we've got this here. Again, we have a hydrocarbon, we have lots more oxygen, but still oxygen going to form carbon dioxide and water. So if you see carbon dioxide and water as a product, chances are it's a combustion reaction. And if you look over on the left-hand side and you have oxygen and a hydrocarbon as your reactants, then it's definitely a combustion reaction that is occurring.